It's often useful to be able to calculate areas and distances. In this task, you'll learn how to calculate the square mileage of each neighborhood and then calculate the population density. Here I have QGIS Desktop open with the QGIS map document from Lab 4 Task 3 loaded. To begin, I'll open the attribute table for the neighborhood diabetes layer. I'll add a column and then populate that new column with the area in square miles. To begin, I'll click the Toggle Editing Mode button. This puts the table into edit mode. It also puts the spatial layer into edit mode, so you may see the vertices of the neighborhood show up as red X's. Several buttons now become active on the table toolbar. I'll click the New Column button to open the Add Field window. For the name, I'll enter square mile, and for the type, I'll choose decimal number. I'll give it a column length of 5 and a precision of 1. This is the number of decimal places the column will hold. Then I'll click OK. I'll scroll to the right to see the new column, which will be empty. Next, I'll click the Open Field Calculator button. This window allows me to populate the new column with values. First, I'll check the Update Existing Field option. Then I'll choose square miles as the field to update. I'll set up an expression in this leftmost window. There are operators in the middle window with some information on the right. From the list of functions, I'll expand geometry. I'll double-click on the $area operator and then click on the multiplication symbol. Finally, I'll enter the conversion factor from square feet to square miles. With the expression complete, I'll click OK. The new field is now populated with the square mileage. Now I'll add a second column and name it population density. The type will again be decimal number with a width of 6 and a precision of 1. And I'll click OK. I'll reopen the field calculator. This time I'll expand fields and values from the functions list. I'll divide the population by the square mileage to generate the people per square mile, or density. I'll set it up so that I'm updating the existing population density field. Then I'll double-click on the population column F2010 Pop. I'll click the division symbol and double-click on the mileage column square miles. With the expression complete, I'll click OK. To save my work, I'll click the Toggle Editing button and save my edits. Then I'll close the attribute table. To show these new data, I'm going to duplicate the neighborhood diabetes layer. I'll right-click on it and choose Duplicate. I'll then open the Layer Properties General tab for the duplicated layer, and I'll rename the layer Population Density. Then I'll switch to the Style tab. I'll again choose the graduated renderer, but I'll set the column to population density. I'll leave the number of classes at 5 and the mode as quantile, but I'll set the color ramp to blues. Then I'll click Classify and OK. I'll turn off the original neighborhood diabetes layer and turn on population density to see the new data. Now I'll add another column to the neighborhood diabetes layer and populate that new column with the density of diabetics per square mile. So again, I'll open the attribute table and put the table into edit mode. I'll add a new column and name it diabetes density. The type will be decimal number. The width will be 6 and the precision 1. To populate the new diabetic density values, I'll show you a fairly new table editing widget that you'll notice has turned on up here whenever we put the table into edit mode. I'll set this up so that I'm updating the existing diabetes density column. Then I'll click the expression button. The expression will be Baltimore City diabetes divided by square miles. So I'll expand fields and values, find the Baltimore City D column, click the divide operator, and then click the square miles column. With my expression set, I'll click OK, and then I'll click the Update All button. This can often be a much quicker way to populate field values. With that done, I'll toggle out of editing mode, saving my edits, close my attribute table, And I'll again duplicate the neighborhood diabetes layer. I'll name this diabetic density and style the data based on the new diabetes density information. In this lab, you've learned the basics of performing spatial analysis within QGIS Desktop. QGIS has very robust spatial analysis capabilities, and we've only seen a very limited set. Almost anything you can envision is possible if you have the data to support it. So I encourage you to continue to explore the raster and vector menus, and I should point out that there are also hundreds of additional tools in the processing toolbox. Additionally, the GeoAcademy GST 102 course offers additional spatial analysis resources, and this same material has been updated to QGIS 214 in the Discover QGIS workbook available through Locate Press.